Flooding, as one of the primary disaster types in the United States, usually happens during the summer period. There are many factors could lead to the inundation inside the city area, like the large participation brought by the hurricane or imperfect disaster infrastructures. For this project, we are going to present our inundation prediction model by using the city data from the Calgary, Canada, to build a logistic regression model which could predict the potential inundation area for other cities. In here, we choose the city of Houston as the city we want to predict because Houston just gone through a flooding in the year 2017, which caused many serious damages to the city. Through building a logistic regression model in R, we are able to apply the inundation data of Calgary to the city of Houston, Texas, to predict the potential inundation area during its yearly flooding time. After we prepare the initial data, we are using the software ArcMap. We import the data into the RStudio and build the prediction model in R. We collected 9 predictors from the city of Calgary as our independent variables, and we will build a model to see the connection and interrelationship between 9 predictors and our dependent variable, the inundation data. By using the prediction model we built for Calgary, we expect to answer 2 questions about city of Houston. What area will be influenced when the flood coming, and what factor would influence or lead to the inundation area? We first import the Calgary's fishnet into R, plotting the city's inundation area, expressing by the dark blue in the map, that is the Calgary's flooding area, and the non-inundation area, expressed by the color of white. There are a total of 9 predictors we use for building the prediction model by using the Calgary data. Through turning the initial data layer to distance maps, we could see the distance from each map cell to that inundation factor. Darker color indicates the further distance to the factor. We use the exact same 9 factors for the city of Houston, so that we could use the same type of dependent variables to predict that city's independent variable, which is the city's potential flooding area. Those 9 bar plots indicate differences in our independent variable across land that has and has not inundation. We could see that in the most of variables, the map area that is not being affected by the inundation had further distance to those 9 independent variables. For example, in the first graph, area that is further to river is more likely to have no inundation. We did the in-sample prediction first, using the data of Calgary. Then, we want to know how well the model performs on the unseen data. We separate the data into 2 parts, 30% randomly selected test set and 70% remaining training set. The AUC, namely area under curve, at 0.73. The value of AUC is not high enough to achieve the level of high accuracy, meaning that the model we built could still be improved. The sensitivity of predictions is relatively high, which is 0.95, but the specificity, which is also called the true negative rate, is not high enough. The result for the out-sample prediction is fine, and we receive a final accuracy of 0.95, which means the variability of accuracy across all 100 folds concentrates on 0.9 to 0.99. Prediction result. We successfully run the logistic regression model for the city of Houston to predict its potential inundation area when the flood comes. In the result map, the darker color represents a higher possibility that this area will be affected by the future flood. When the flood comes, area with darker color will be affected firstly, and may suffer more serious damage than light color areas. Through comparing our prediction result to Houston's historic flooding area, we think the model runs well and could achieve 80% accuracy in predicting other cities' future inundation area.